Hello and welcome everyone. Today we'll dive into LangGraph. But before I can show you some of the concepts and features that LangGraph provides, I think it is important for us to understand what a structured response from a language model means, and also what's a function calling, or in other words, tool calling. So this will be like a comprehensive video about everything, and then eventually we will move on to LangGraph. First of all, I would like to show you some basics of LangGraph without any kind of AI built in it. And then I will move on to conditional edges with some logics in LangGraph. And then I will show you what function calling is, what tool calling is, what a structured response means. And then I will show you a full-fledged example of tool calling, LangGraph, state management, right? So what is LangGraph? LangGraph is a library. So this is the LangChain's LangGraph page, and this is the version 2, I think 0.2 of LangGraph, and this is one of the latest versions of it. So it is a powerful library that is doing state management while you are interacting with your large language model. Right? So what that means is your large language model is generating outputs, and then you are keeping track of various states during the processing of your prompt. Right? So for example, if you ask that, hey, what is the weather in Woodbury? And the large language model has to look up a particular tool to respond to it. And then once it responds back, you want to store that state and then use it in future for some other use case that you have, right? So for example, if it is too hot, then you want to turn on the AC, or if it is too cold, then you want to turn on the heater, right? Or just turn off the whole air conditioning system for whatever reason. So if you want to maintain the state, then you can save your state in a particular agent state, and you can modify the state of your application throughout the life cycle of the application, essentially, right? So you can modify this state throughout the life cycle, and let's see what all that means. So as a very first step, I'm going to show you a very simple example, and this example is something like this. So we are gonna have a few nodes, right? And this example is nothing, it is very simple. We're gonna have a few nodes, and these nodes are just without any rhyme or reason, just going through these edges, and then they are coming to an end. And each node essentially in LangGraph means that it is a function. It's a function that takes in a state, and it's a function that outputs a state, and that's it. In reality, LangGraph has nodes, and those nodes take in a state as their input, and they output a state also. And they pass on the request from one node to another node. For example, in this case, we are passing the request from node 1 parallelly to two nodes, node 2 and node 3, and then node 3 and node 2 are then just passing it back to node 4, and then we are ending the request. So this is a very simple, straightforward split node example that I want to show how it is built in LangGraph. So in this, you first define that what your graph is, right? So you start with a message graph, and then you define your node IDs. So these are the 4 nodes that we were looking at, and we are just defining the 4 node IDs. And then what you do is you create your actual nodes. So for example, node 1 is defined by its node ID and the function that it is processing. So in this case, we are having all the 4 nodes exactly same that are taking in this function as add text in it. So what does this function do? It just adds amazing to whatever has been passed on to it, right? So if you have node 1 being processed, then it will just add amazing underscore to it, to whatever text is being passed to it, and then underscore amazing again over here, underscore amazing again over here, and then underscore amazing again over here. So in this particular flow, because it's the same function that all 4 nodes have been assigned to, it's just gonna add underscore amazing to all the different from all the different nodes, and that's what we're gonna take a look at. So how you define your nodes is just by the node ID and whatever function that you have, right? So in this case, we are just having add text function, and you are gonna create your 4 nodes now, but you haven't linked those nodes yet. So in order for us to link the nodes, if we come back and take a look, so node 1 passes on to node 2, and node 1 also passes on to node 3. So we have to create these 2 links. So let's go back and take a look. So in our case, we add an edge now, and node 1 to node 2, we are creating a link over here. And these links are done by the IDs of these nodes. So node 1 has an edge from 1 to 2, and then there is an edge of node 1 to node 3. And these are the 2 edges that we're talking about, 1 to 2 and 1 to 3. Let's go back. We also have edges from 2 to 4 and 3 to 4. Let's go back and see 2 to 4 and 3 to 4, right? So we have the whole edges defined by adding the edge to the graph. And there is no conditional statement, nothing over here. It's just saying that, hey, create these nodes over here like this, create these edges over here like this, add end edge to it on node 4, and set an entry point for node 1, right? So we set an entry point for node 1, and we set an end edge for node 4. This is all that it is doing. It's a very simple example. And then you can do a graph.compile. And once you do a compile, that is when your runnable graph is ready. And then this is a small helper method that I have written that outputs an image. So this image that you see is being created by this particular helper method over here. So you can take a runnable graph and you can create an image out of the runnable graph. And this is pretty cool because now you can visualize how it looks like. So I've already run this and that's why this output graph is created. And if you want to see how that works, I'm going to delete this from here and move to trash. And if I run this a program again, so let's do Python 01 basic LangGraph.py, it will create that particular file for us. You see, it created this file right now for us. And if you take a look at the file, it is the same file that we were seeing earlier. All right. So for this to work, right, it is taking the runnable graph that we have compiled, and we are invoking AI is as a string that we are passing on to node 1, right? So why node 1? Because we have set the entry point as node 1's ID. So node 1, we are passing AI is, and then from there, we are flowing the information from node 1 to node 2, and then node 2 adds. So if you come over here and see, so node 1 adds is amazing. So that is the very first amazing that is added by node 1. Node 2 adds amazing again. Node 3 adds amazing again. Node 4 adds amazing again, right? So AI is being just passed on to node 1, and then all the 4 nodes are adding the same text onto it. So this is very cool, very simple, basic example that I like showing so that it makes it very clear. There is no AI interaction over here. It's so you can use LangGraph as a simple flow for your other applications too. Now, what makes it interesting is that you can now use some conditions over here. So you'll say that, hey, Mukul, how is this useful now, right? I mean, you are just passing. There is no conditions. There is no nothing. How are you doing anything useful over here? So the use comes into picture when you start adding conditions to these particular edges that, hey, if whatever condition has been met, then go to node 3, otherwise go to node 2, right? So those kind of conditions and conditional edges we can build, and that is what we're going to take a look at next. So in this next example, again, this is the output of this particular graph. So I've already ran this first, so I can show you this graph. So if you take a look at this example, there is a node ID called entry, right? So in previous, I was just using node IDs as node 1, node 2, node 3, node 4. Not very meaningful over there, but because all nodes were having exact same functions attached to it, so that's why I just named them node 1, 2, 3, and 4. But let's move on to the second example, where we have the first node's ID as entry. The second node's ID is AI. The third node's ID is human, and fourth node's ID is finish, right? And then these are the conditional edges. And if you see, the conditional edges are marked by dots over here. And what it means is that if the condition is AI underscore node, then it goes from entry to AI node. And if the condition is human node, then it goes from entry to human node. And what do I mean by if the condition is? So we can check for a string value that, hey, if that particular string value, whichever we have over here is AI underscore node, then go over here, otherwise go to this particular human node. And let's take a look at the code, and it'll be more understandable from there. So you see, I have created these 4 node IDs. So node 1, 2, 3, and 4 have now more meaningful names over here. So entry, human, AI, and finish. These are the 4 node IDs that we have created. And we have 4 functions. So each node has its own function associated with it now. So if you remember in previous example, we were just using the same function for all the 4 nodes, but in reality, we will use each node has its own function, right? So we haven't associated these functions yet, but you can kind of tell that these functions are for these particular nodes, right? So we create these functions, and in these functions, the very first entry does nothing. It just takes in the input and just passes it along. So it does really nothing. The entry node that you see, the second human node adds is not amazing to it, right? So it just adds the text, is not amazing. Whereas the third node, this particular function adds the text, is amazing to it. And then finish just adds the text, always to it, right? So we have separated it out so that this looks more meaningful. And now what we're going to do is we will add some condition or router node over here, right? So what does a router mean? So if you have a condition which says that, hey, if it is AI node, do this. If it is human node condition, then do this. This is the router that we are talking about, that instead of hard coding it from first node to the second node and first node to the third node, we are going to have a router condition over here in place. So let's take a look how that's done. So we first define this particular router node, this function. So the router is also a function for us, right? So we first define this router and we say that, hey, whatever is our condition, in our case, the condition is if the content is human. And where is this content coming from? We'll take a look at it in a second. But if this content is human, then go to the human node. Otherwise, go to the AI node, right? So this is just a string that is being held, and then we will see how this is being used very soon. So now we start adding our nodes. We start creating our nodes, right? So how do we create the nodes? We take the graph.add node, node ID, and the function, right? So I'm going to quick go back to the first example so you can make a correlation. You see, we created node by providing node ID and the function, right? In the same way, we will create the node by node ID and the function, right? So node ID is entry and the function is entry over here. So that is what we are doing, node ID and the function, and we are creating our 4 nodes, right? So let's just create these 4 nodes and then we will worry about routing logic over here. Okay, so now that we have created these 4 nodes, we have to now add the edges between the nodes, and the very first edge from node 1 to node 2 or node 1 to node 3, that is the conditional edge. So what we are saying is that, hey, from node 1, how do you go to node 2 or node 3? You use this router, you use this function. And this function says that, hey, if the value that is returned by this function is human node, then go to node 2. If value is returned as AI node, then go to node 3, right? So this is what it is saying. This is how this router function works, that, hey, it can return either human node or AI node. And if it returns human node, go to node 2. If it returns AI node, then go to node 3. And this is how the conditional edges work. And now, after you have reached node 2 or node 3, you have to come back to node 4 either way. So if you take a look, once you have reached node 2 or node 3, which is AI or human, it doesn't matter which path you came from, you have to eventually go to the finish node. And then this is what we are going to build over here. So it doesn't matter which node you land on, 2 or 3, you have to eventually go to node 4. And from node 4, you have to go to end. So this is a very simple basic conditional node example. And after this, you set the entry point to node 1, and then you compile your graph and you visualize your graphs. And this is the same helper method that I created earlier, and it outputs to output02.png, which is this particular file. And then now in the entry point, right? So node 1 ID, which is the entry point. In the entry point, if you pass in AI, right? So let's do that. Let's run it. Python 02 and conditional edges.py. And if you pass in AI, then it flows from. So now the entry point has the text AI in it, and then the conditional route flows it to AI node, and then it flows it to finish node. So this is how it is working, and we'll take a look at the code, how this is flowing. But I want to show you that the entry point has been given AI as the input text. The conditional route took us to the AI node, which then routed it to AI, and then it eventually went to finish and went to end. So we are seeing AI, which is the entry node, is amazing, which is coming from this AI, always, which is coming from the finish, right? So this is the route that was taken. And if we go back to our code, we can take a look as the entry point node 1, right? So on node 1, we just pass in, and there is nothing that is happening over here. So we just pass in the input without any modification. So AI gets passed in over here, and then after the first node, there is a condition that's happening, right? So what is this condition? So it is that, hey, if the text that is passed is human, then go to human node, otherwise go to AI node. But the text that is passed is AI, so it is going into the else condition and it is going to the AI node. Let's pass human in the text, and then it will return the human node for us, right? So let's do that. Let's pass. Instead of AI, let's pass human over here. And if we pass human, then the flow should be to the human node. And let's see if that happens. So I'm going to run this again, and it will say human is not amazing always, right? So human is, this is the input human, and then the human node got called is not amazing, and then finish always, right? So anytime when you pass AI, it goes to the AI route. If you pass human, it goes to the human route. And this logic is the router logic, conditional router logic that we have associated. And I'm just gonna quick show you this again, the router logic. So you define router as also a particular function, and then you associate the conditional edge, right? So you associate graph.add conditional edge, and from node 1 to the router logic node, right? And the router logic has inbuilt either a human or the AI node. Okay, all right. So now that we are done with the basic and the conditional, I wanted to show you a special, like, how do you execute a condition, right? So let me show you the graph over here, and it will make more sense. So in this example, what we're going to do is we're going to define an agent, and that agent will check whether a particular tool is called with a condition, right? So this is a very simple example where I'm gonna make this agent call the tool called tell joke 10 times. And if it has told me 10 jokes in series, right, then after the 10th joke, I will say, okay, enough, and let's end this sequence. So how this works is that at the start, I will first check for a condition whether the counter is equal to 10. And if the counter is not 10, then I will invoke a conditional edge and I will say, hey, go to the tell joke node. And if the counter has met its condition, which is 10, then go to the end condition node, right, which is the end. So we are, how many nodes do we have over here? 1 and 2, only 2 nodes we have, right? Start and end, they just come part of it. And the entry point is our agent, and the another node that we have is a tell joke node, right? So we are gonna pass the control to agent. Agent will perform the counter check, and then if the counter condition is met, then we end it. If it is not met, then we keep on going to this particular loop of telling the joke, right? So let's take a look how this is implemented. So if we see, we are gonna use ChatOpenAI model. We could have used OLAMA too, but I'm just going to use ChatOpenAI for this purpose right now. But I'll show you what we are going to use for function calling and unstructured response later on. But for this particular use case, we are just going to use simple ChatOpenAI because OLAMA also supports the OpenAI format, right? So we're just gonna use this ChatOpenAI base URL. You will notice that I have hosted it at 11436. And if you want to see why this is, then just take a look at the previous video where I have talked about Nginx and load balancing to OLAMA servers. This is one of my load balanced OLAMA server, and this is actually one of the nodes of the OLAMA server. But in your case, you can just use localhost :11434 /v1 for your ChatOpenAI endpoint. So this is the v1 endpoint that supports your OpenAI format request responses. So localhost :11434 is what you will need to put in over here for the base URL. All right. So once you have defined your chat model, you're going to have your message graph defined over here. And you see we are not passing in states yet, right? So we are not doing anything with the state in this example. Also, we are just using simple LangGraphs flows up until now, right? So we define a graph as a message graph, and then this is our joke call counter, right? So it is 0 at the start, and then we have only 2 nodes, agent node and tell joke node, right? Let's take a look again. So we have agent node and tell joke node, only 2 nodes over here. And now let's go back over here. And so we are defining these 2 nodes, and then the function for agent node is called agent, and the function for tell joke node is called tell joke, right? And it just makes it easier. So I define the node ID separately, and then I just clearly mention which particular function they're going to use with the same name as the node IDs over here, right? It just makes things very easy. Now there is a condition over here, right? So the router condition is if the joke call count is less than 10, then go to the tell joke condition, otherwise return the end condition, right? So if we go back over here, take a look at this. So we are going to have the router condition, right? So this is the router, this or this node, right? This is the router. The router condition is that, hey, if the counter is less than 10, then keep on telling me jokes. If the counter has met its criteria of equal to or greater than 10, then just go to the end condition over here. So this is what is this router logic. If you see, tell joke count is less than 10, tell joke condition, or return the end condition. And now we're going to add these 2 nodes. We only have 2 nodes, remember, so we're going to add these 2 nodes to the graph. So node 1 with the appropriate function, node 2 with the appropriate function, right? And then from node 1 to either node 2 or to end, we are gonna have this conditional edge, right? This is what this one is. So either tell joke node or the end node, we have a conditional edge. So if you take a look, we are hitting node 1 and then we are saying that, hey, add a conditional edge from node 1 with this router condition. And if the router returns tell joke, then go to node 2. If the router returns end condition, then just end it. Right? So this is a very simple agentic flow that we have over here. And then we'll add the edge to the graph from node 2 to node 1. So if you see over here, you always go from tell joke to agent, right? So after you are done telling the joke, right? After you are done executing this particular node, you can never go to end. You always have to go to agent, and agent is the one that determines whether I have to end the sequence or I have to end the sequence or I have to continue telling the joke, right? So this is the critical part, that condition only. The end condition is governed only by this agent. So the agent can determine whether you want to end or you want to tell a joke or not, but the tell joke node can only return back to agent. It has a solid arrow back to the agent, right? And that is the very important aspect of this particular flow over here, that from node 1 you can go to either node 2 or end, right? You can go to either node 2 or you can go to end, but from node 2, you can only return back to node 1. This is a very important aspect of it. Now we set the entry point to node 1. We compile the graph as usual. This is a helper method to visualize how the final compiled graph looks like. And this is the output 3 that we are looking at. And now let's just pass in the invoke. Let's do the runnable graph.invoke. So because this is runnable, you can do an invoke on it and you can say that, hey, tell me a joke about nature, keep it funny. And recursion limit, you don't need this. I mean, I think by default you have 25 as the recursion limit, but if you want to override that, like if you want to change this number over here to more than 25, then you have to add the recursion limit to more than 25 over here essentially. But in our case, because we're only checking for 10, so it doesn't matter. Okay, all right, so let's run this. Python 03 conditional edge with logic and hit enter. So now it's gonna it's loading the model right now. So the very first load, let me see which model I have over here. So llama 3.1 small model, and that is why it ran pretty fast. So you see joke call count 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and then it ended over there. So it did the 10 jokes and then it ended. So this is cool. This worked. Now this is where the more interesting aspects of LangGraphs can be used. If we switch from regular flows to a more state managed flows, right? And in order for us to do that, in order for us to take a look at a state managed flow, I think it is very important for us to understand what function calling is or what tool calling is. And I'm going to do that in the next video that I make. So in the next video, we're gonna see what function calling is with a simple example, and then we're gonna see what structured responses are, and then we will see a full-fledged LangGraph example with the state management in it. All right, thank you guys for watching this video and stay tuned for the next one.